In this lab, you will develop a Verilog module for the Digilant Nexys, a 7100T board that continuously reads the state of all 16 onboard slide switches and drives the 16 corresponding LEDs. Your design must ensure that each LED reflects its paired switch in real time, giving you hands-on experience with basic digital I/O operations on an FPGA. Along the way, you'll learn the complete FPGA development flow, declaring and mapping I/O ports in your HDL code, authoring and applying an XDC constraints file, running synthesis to translate your Verilog into hardware, and generating and programming the final bit stream onto the FPGA. By the end of this assignment, you'll have mastered the key steps needed to turn HDL descriptions into a working FPGA design. For this lab, we'll be using the Digilant Nexys A7100T development board, which features a Z-Lynx Arctic 7 FPGA at its heart, and provides 16 onboard slide switches alongside 16 corresponding LEDs. This ample array of simple user I/O will allow you to verify your design by flipping each switch and watching the matching LED respond in real time. You can pick up the exact same board under Digilant part number 410, 292, readily available on DigiKey and other major suppliers. To get you up and running quickly, we've supplied an XDC constraints file template that already maps each sub-UI symbol to its physical switch pin and each LED symbol to its LED pin. Simply load this template into your Vivado project, add your Verilog source, run synthesis, and program the FPGA without worrying about manual pin assignments. Now let's look at the core logic in Verilog. We define a module called switch_LED_interface with a 16-bit input bus for the switches and a 16-bit output bus for the LEDs. Inside, there's just one line of code. Assign LED equals sign SW. That single assignment ties each LED directly to its matching switch. Flip any switch and the corresponding LED lights up instantly. No clock, no state, just pure combinational wiring. It's the simplest way to verify your I/O mapping, synthesis flow, and timing on the Arctic 7 FPGA. Next, we'll map our logical ports to the physical pins on the Nexys A7. Open the Nexys A7100T master. XDC file in Vivado. For each switch, add two lines, one to bind it to its FPGA pin and one to set the I/O standard. For example, for SW0 you'd write set_property, package_pin E3, get_ports SW0, set_property, I/O standard LVC-MOS33, get_ports SW0. Then do the same for LED0, specifying its pin. After that, repeat this pattern for SW1 through SW15, and LED1 through LED15, using the pin names from the Nexys A7 reference. Once all 32 assignments are in place, Vivado knows exactly how your switches and LEDs connect, so you're all set to synthesize and program the board. Alright, now let's talk grading. Half of your lab grade, 50%, comes from the live demo. You'll sit in front of the board and flip each switch to show its matching LED lighting up. The other 50% is your written report. In that document, include your Verilog source, the XDC pin mapping snippet, and synthesis screenshots showing your LUT and flip-flop usage. Don't forget to drop in the link to your group's demo video and add a few sentences reflecting on what you learned. That's it. Demo and report, each worth half, for a full 100%. Finally, let's cover the group video requirements. Your team should produce a 3 to 5 minute YouTube video, either unlisted or public, that walks through your board setup and shows it working. In that video, every member needs to appear on camera and say one sentence about what they did, whether they wrote the Verilog, handled the XDC pin file, ran synthesis, or did the testing. That way it's clear who did what, and everyone gets credit for their part. Finally, here's how to submit your work. First, create a GitHub repository named ECE3300 Lab 1. Inside that repo, organize your Verilog source and XDC files into their own folders, and include a readme.md that explains your project. Next, bundle everything into a zip file called lab1_.zip. That zip should contain your Verilog and XDC files plus a PDF report with your synthesis screenshots and the link to your group video. When you've pushed your repo and uploaded the zip, you're done. Just make sure it's all on GitHub by June 18, 2025 at 11:59 p.m.